Okay, so let's recap what we did yesterday. So yesterday we wrote a little demo script to kind of demonstrate how to make manual HTTP requests to our Olama server so that our Olama server can actually then interact with the LLM to generate some text and then give it back to Olama, and then Olama just responds through HTTP back to our script here. And we ended up setting all that up, and we found that it was really easy to just put it into our game. We had a self-prompt instance variable where we would actually load the prompt.txt directly here, prompt.txt, into a string using fread, f being our file object, okay? And then when we would verify answer from actually remember our loop was like play, we call verify answer after the user types their answer. We call this method, and then our code was almost a copy and paste from our LLM demo.py. I don't think we changed much when we did this, right?
Mm-hmm.
Yeah. So as you can see, it's kind of long, and I don't think it's very ideal. So I think we might need to create a class here that actually handles interaction with the LLM. And we could probably call this like LLM Client or something like that, where we can actually then abstract all this complicated request building and prompting away and just make it a simple method call set, like maybe like verify answer or something like that.
Mm-hmm.
Okay. Yeah. So let's do that. So let's go to Excalidraw. And let's see here. Ugh, too big. Still too big. Okay, perfect. Okay, so our current architecture. Our architecture right now is the Olama server. Okay, and this is just pretend that it covers also our LLM. In this case, that is Llama 3.2 8B, was it instruct Q80, whatever you call it. That's a model, right? That's LLM. And here, I'm going to make it bigger, draw this bigger, is our app, or in this case, study buddy. Okay. We have our main.py, right? Which is just like a front end. And that actually has a game with play. Okay. And it also contains a deck. And a deck has multiple cards. So far, so good?
Yep.
As a user, I interact with main.py.
Mm-hmm.
Okay. Now, right now, when we say play, that creates an HTTP request to the Olama server. And then the Olama server gives back. Actually, let me just do this. Gives back a response directly back to the game. Okay?
Okay.
So that's the current state of the world. But I think what we should do is create a new thing here called LLM Client, where now this HTTP request and response interacts through the LLM client. Oops, I did the wrong direction on the arrow here. Like this. Make sense?
Yep.
The gameplay will actually interact with the LLM client. So now we only need to focus on this thing here.
Mm-hmm.
Okay? So this is just going to be a new thing, right? We'll probably call LLM client dot py or something like that. It'll just contain the same code that we just wrote. Okay?
Okay. Yeah, sounds good.
Yeah, so I think our LLM client.py could probably be something like validate answer. I think it's like this. Yeah, we'll have a method called validate answer where we'll have the question, the answer, and then the attempt. Okay? It's one method, just one method. Okay, so let's actually start writing that. So I'm going to create a new file. I'm going to call this LLM. I'm going to client.py like this. It feels like I haven't used underscore, and it's just weird if I start introducing it now, like data loader and whatever. Okay, so first things first, I'll do client, or not client, class, LLM client. Okay, and I'll have an init. That's a self. And right now, let's just pass.
Okay.
I'll also have a validate answer. And that will have a question, an answer, and an attempt. And I'll just pass. Okay? Now, I think it's just as simple as this. I think, honestly, we can just take stuff we've done here and just dump it in here again. For example, this will automatically load up our prompt by just constructing. So we'll have a default, you are a helpful assistant. Okay? And remember, the prompt is going to be sent as the system message to tell the LLM what to do.
Mm-hmm.
And then we'll have with open prompt dot text. Okay. As F, basically the file. We'll do self dot prompt. We'll overwrite it with F dot read. Okay. We'll overwrite the default with whatever we read in from the file. And then here's our logic here. We can just basically build up our user message given our question, answer, and attempt here. So we can just copy and paste, basically. So if I were to just do that, paste it here, we have our user message. And by the way, VinMotion DD is to delete lines. And then if you want to indent, you can just do Shift V and then the angle bracket multiple times to move lines like that. And then if you want to add a new line with just the keyboard, remember all this is normal mode. You can just press O and then you'll create a new line. So press O like that will create a new line.
Okay.
Yeah. So so I'll just basically highlight all of this, yank it, and then I'll just paste again. That's our payload. So self.prompt already exists as an instance variable of our LLM client class. Also, user message is already built up here, given the parameters here. And then what else do we need? We also need headers. Okay. I feel like we should just create this as an instance variable too, so that we don't have to recreate headers every time, like recreating new objects for efficiency.
Uh-huh.
Yeah, I think we can just do self.headers here.
Is it normal to create and open files within the init? Like,
not really.
Yeah.
It's actually really bad. It's okay. First of all, there's problems with that. Okay, so first of all, disk I/O is always slow. Like you just think about from memory to like memory is like order of nanoseconds, right?
Mm-hmm.
To read from from data. To read data is like nanoseconds, and for disk, to read is like millisecond. That is like, what is that? I don't know, like 10 to, it's like 1,000. No, it's like 1,000,000 times slower or something like that. So what you're doing here effectively by putting reading from disk in the constructor is that you're slowing down building disk object.
Mm-hmm.
Right? Just the act of creating an instance of the LLM client class, you are effectively, or at least me, I am effectively slowing things down. Okay, now I'm like, okay, maybe that might be fine. I'm only creating one of these clients, right? One of these objects. But let's think at scale here. What if I had to create like hundreds of them or thousands of them? Then I just create a bottleneck in the system.
Mm-hmm. So
So
should it be created in another file and then imported as the header and then built from there? Would that
you
be
mean
better?
the header or the prompt?
The prompt.
The prompt, right? Like this,
Mhm.
right?
Yeah.
Uh that's a good question. I think should we just okay, that I think you have a really good point. I think that's a good call out actually. So what you're saying is why not receive this as like argument to the constructor and just do this once.
Mm-hmm.
Pass
Yeah,
that in.
because like I think it'll be an issue if we had to like build, let's say, like 1,000 of these.
Yeah. Yeah. No, that's a
Mhm.
fair point. Yeah, you know what? Let's do it. Let's not be lazy. Let's do it the right way. So let's do prompt reader.py. Okay.
Mhm.
And then we'll just do class. Wait, do we even need a we don't need a class. We just do what you just did, right? Yeah, let's just have a quick class. Okay, let's just have a quick class. Okay,
Mhm.
so let's just do class prompt reader and then def read prompt. Okay, and that will
Mhm.
just basically return us back. You are a helpful assistant. That can just
Mhm.
return us back the string, right? And
Yep.
then okay, and then this will be the read file part with the open prompt dot text as f dot oops prompt equals f dot read like this.
Mhm.
Yeah. So then we only need to do this once, and then if we created 100 or 1,000 of these LLM clients, I don't think it matters. It just read it once, so we can just say prompt because we're gonna pass that in instead. So if we had to create like 1,000 LLM clients, we could just keep passing in that same prompt.
Yep. Sounds good.
Okay. Okay. Okay, and we can cache this thing here, and if any of the viewers are still confused, I think they'll see what you meant very soon enough. Okay,
Mhm.
so um, okay, so I'm gonna say okay, I'm gonna take in prompt, and I'm gonna just assume that we'll read the prompt down the line and pass that in. So good call out. I still think that self headers is just a dictionary. It's created in memory. We just don't want to recreate a dictionary every single time we validate an answer. So that's okay. Let's just keep that as an instance variable. That makes sense to you.
Yep, that does.
Yeah, because it never changes. It's always going to be the same. So now what we want to do is we're going to fire the request and then process all the response stuff. So we just copy that and then we'll paste it. And then we need to also import request and JSON. So import requests, import JSON. By the way, I really like your feedback right there. Thank you for that earlier. So um, payload. Oh, I need to indent. Okay. Okay. Okay, and this needs to be self.headers. Okay. What else? Why am I getting squigglies? Oh, I need one more indent. Okay. It's hard to tell when your screen is so small. Okay. Okay, there we go. Okay. So now I have this LLM client. If I were to just do this, I have a class implemented now that's specifically in charge of just validating the answer with the LLM. And it does look a little cleaner, less noise away from the game. So let's get rid of this code here. Okay, let's also get rid of all of this here. Okay, and then we can also now, why not we just create, so we only have one game, right? So we can just say LLM client equals, and then we'll import LLM client. So from LLM client, import LLM client. And then we'll say something like LLM client with, it needs the prompt. So we still need to read in the prompt up here at least. That's fine. So prompt is going to be, because we only create one game object anyway. So should I say with open prompt dot text? What do I say here? As file, as f. I'm going to say prompt is going to be f.read. Okay. And then we'll inject prompt here, give prompt a default value. You are a helpful. Wait, I just did this. Hold on.
Yeah.
I just do prompt reader. Prompt reader.
Okay.
Yeah, prompt is
Okay.
new. Wait, prompt reader. Read prompt. Done.
Yeah.
Okay.
Okay.
Yeah, sorry. Just trying to think on the fly because I didn't realize this, and that's a very good point. So okay, so we read in a prompt with prompt reader, get that text, and we inject that into our LLM client. Now we have an LLM client. Okay, then down here we can just do return self.llm client.validate answer question answer attempt. And it's as easy as that. Okay. Okay. Well, oh, I'm on caps lock. Okay. So let's test it. Let's just make sure that we didn't break anything. Our main is still intact. All good. I'm going to delete this LLM demo. So it's just going to confuse us. So how do I delete? Delete here. Okay. So now if I were to just bring this up here, I'm going to clear and I'm going to run the script again. Okay, what's OSI layer 5? That is going to be the session layer. Okay, I got that right. Oh, I got that right. Okay, so the LLM verified it. Okay, I'm going to say, okay, the OSI layer 7 is application layer, right? Well, I'm going to give it a twist. I'm going to say app layer. Let's see what happens. I indeed got it right. Okay, just so we can make sure we didn't break the LLM, I'm going to say OSI layer 6, even though it's the presentation layer. I'm going to say it's a transport layer, layer 4. I got it wrong. Better luck next time. Brilliant. So this is good.
Okay, nice.
Yeah. And notice how we don't have to be exactly say app layer, and it'll say application layer. So, yeah. Okay, now let's take a look at all this. Okay. I'm going to commit real quick. Okay. I don't know. I should have just ignored this stuff, but it's okay. LLM access. Okay. All right. Now I'm going to, so we have basically our game. So now going forward, if we wanted to add another card, let's just say this label. Let's do something like let's do what is cooperative multitasking. And then we could say something like description. When processes, a form of multitasking where processes are responsible for yielding back to the OS. Is it OS or CPU? I think operating system.
Mm-hmm.
Operating system.
Mm-hmm.
Okay. So category. Going to be operating systems. Okay. So we have a new card. We can always add new cards this way. So if we were to run our program again, what is cooperative multitasking? When processes give back time to the OS. Okay? Because I'm not gonna when we're really typing, we're not gonna type all this, right? So yeah, so let's see what. You got it right. Isn't that cool?
Yeah, that's nice.
Yeah, that's very nice, right? But there's going to be times where you kind of like remember yesterday we ran into like a problem where sometimes the LLM didn't tell us we were right even though we were right.
Mm-hmm.
Because we're working with like a smaller model. And just pro tip again, when you're doing this, you can remember that you can kind of refer back to what LLM you're using by using Ollama PS like this, and then it'll tell you what model you're actually using.
Mm-hmm.
So this is interesting because I'm going to make this claim here in that we can train the LLM to be smarter.
Mm.
Okay.
Yeah.
I think that just involves adding additional information into our message, the user message, the message that we send. And now that we have LLM clients, really easy to see now. The message here. Okay.
Mm-hmm.
We could perhaps do things like this, where we insert yet another thing back here, where we say, let's see, hints. And then we'll give like a list of answers that are possible. And LLM can use that to kind of cross-match this attempt along with the answer to give it more confidence. Does this make sense? Yeah, like a hints will be like a bunch of hard-coded text, right? And I think every card should have like another thing called hint, where the app layer, application layer, app thing layer, things like that, where if the LM sees all of this and you give like an answer that doesn't really quite match the answer but is following some of these hints, it can still say it's right.
Okay.
In effect, you're making the LLM smarter.
And is hints a key that we can set, or is it already is it set by Ollama? Like
No. This is something we're going to have to send as a part of our message in the background.
Okay.
Like for every single one of these question answer attempt pairs or triplet, we're going to add a fourth one called hints, where we send the corresponding hint string to that card.
Okay, got it.
Every card will have hint. Okay, so that's for next time. That's for future, actually, future. Because I think we've had our fill right now for LLM. I think you're very you're very curious right now for a preview of what's to come. And what's to come is that I'm pretty sure you're getting tired of working with this JSON. I think it'll get big eventually, and it becomes a hassle to manage.
Yeah.
Yeah. So next time, let's take our architecture a bit further, and let's now introduce SQLite database to store all the cards.
Okay.
Yeah. And so that we will pull the cards in from with a SQL query. And
Mm-hmm.
so we can create lots and lots of cards, no problem. It doesn't have to be tied to JSON. So yeah, I think that is definitely for next round. So
Okay. Sounds
yeah.
good.
But I would like to let you know that right now we have a fully functioning game. I mean, you don't even need to have a SQLite database. You can just keep building off of this, right?
Mm-hmm.
Like so, and you also have an LLM client that pretty much gives us good results, right?
Mm-hmm.
But just know that we can always make the LLM smarter, and we can make our data access smarter or data access better. So we're just going to be doing enhancements from here on out. So
Okay.
yeah.
Sounds good.
All right, cool. Yeah, that's about it today. Thanks for joining.
Okay. Thanks.